The Nexus 10 Axial Flow Engine. Next generation sinusoidal propulsion architecture. Nexus 10 is a highly advanced, ultra-compact axial internal combustion engine that completely redefines traditional mechanical efficiency. A heavy, high-friction crankshaft and the inherent mechanical losses of conventional cam-actuated valves. The Nexus 10 utilizes a space-age sun, gears, and planet gears, Valvetrain, paired with an inline, sinusoidal, because the reciprocating motion of the pistons is converted directly in line with the drive core. The mechanical output is not in an opposed or perpendicular direction relative to the chassis. This linear torque path results in an incredibly balanced power profile. The entire system operates with such minimal resistance that it is inherently low friction and can easily be turned completely by hand. Engineered for optimal volumetric capability, the Nexus 10 cleanly revs to asynchronized 2099 RPM when coupled with a 7-speed gearbox. This high-efficiency powerhouse distributes torque so effectively that it can easily propel a lightweight aerodynamic chassis to speeds of over 140 miles per hour, all while maintaining a thermal and mechanical efficiency profile significantly greater than any conventional piston engine on the market today. Core technical architecture, Valvetrain, and gear assembly. The engine features advanced cylindrical valves, rotary sleeves integrated directly into the cylinder heads. This setup replaces traditional springs and lifters with a positive drive planetary gear set. A massive central sun gear drives individual planet gears at each cylinder head at a precise mechanical ratio, completely eliminating valve float. A highly optimized stroke-cycled intake, compression, power, exhaust. Because the cylindrical rotary valves spin continuously, their machined ports perfectly align with the intake and exhaust manifolds in an uninterrupted rotational sweep, maximizing gas scavenging and volumetric efficiency. Sinusoidal kinematics. Instead of standard connecting rods pushing down on a crankshaft angle, the Nexus 10 uses dual-sided piston pairs, tracking a perfectly sinusoidal swashplate track via heavy-duty roller bearings. This results in true harmonic piston acceleration and near-zero side loading on the cylinder walls. Firing order and dynamics. Optimize firing order 13524 per side to maintain absolute primary and secondary balance across the radial array. The Nexus 10 utilizes a classic alternating firing sequence across its 5 radial cylinder axes. Synchronization. By firing every alternate cylinder sequentially, the power strokes overlap seamlessly along the sinusoidal track. Continuous power delivery neutralizes torsional vibration. The Nexus 10 displays immaculate kinematic balance, proven by native stroboscopic subharmonic stabilization phases at 669 RPM, 999 RPM, and 1339 RPM. The mechanical frequency perfectly locks with digital display capture rates. Drivability and torque dynamics. The 2099 RPM optimization advantage, limiting the maximum operational threshold to a clean 2099 RPM, is one of the engine's greatest engineering triumphs. While conventional power plants must scream at 6,000 plus RPM to achieve high horsepower generating extreme friction, heat, and wear, in the process the Nexus 10 achieves its maximum volumetric efficiency at low revs. Effortless drivability. Because the engine delivers massive, instantaneous torque from low revs, it is incredibly serene, equable, and easily drivable in real-world scenarios. There is no need to rev it to find the power. It is always instantly primed. Endurance. Operating at a maximum ceiling of 2099 RPM radically minimizes inertial stress on the internal components, virtually eliminating the primary causes of mechanical failure found in high-revving conventional engines. Gearbox integration and torque continuity. The relationship between the low-revving drive core and the gearbox is where the efficiency truly shines. In standard automotive architectures, conventional automotive designs suffer from abrupt RPM collapses where the engine output vanishes momentarily before the next gear ratio restores torque. Seamless transitions between gears. The Nexus 10 boasts a perfectly flat, linear torque curve due to its continuous sinusoidal power strokes. When upshifting through the 7-speed gearbox, the torque transition between gears is entirely unbroken. Elimination of energy losses. Because the engine doesn't suffer from power fluctuations between gear changes, it maintains a relentless forward pull. The gearbox can utilize wider, taller gear ratios to efficiently transfer this brute rotational force directly to the wheels, allowing the chassis to rocket past 140 miles per hour effortlessly. This harmonic connection between torque delivery and gear spacing ensures that every ounce of energy is translated into pure, efficient, kinetic motion. Coaxial planetary transmission. This is the absolute best match structurally and philosophically, since the engine already uses a sun and planet gear system for the valve. Carrying that design language into the transmission makes perfect sense. Why it works? Planetary gearboxes are natively. The output shaft of the axial engine flows straight into the center of the gearbox in a single, uninterrupted line. This eliminates the need for parallel shafts or bulky countershafts that compromise a compact, aerodynamic chassis. By distributing the engine's massive low-end torque across multiple planet gears simultaneously, the load on individual gear teeth is heavily reduced. It easily handles brute force without attenuation. 1. Manual track mode. Raw sequential engagement. When switched to manual, the computer steps back and hands control entirely to the driver via steering wheel mounted paddles or a sequential gear lever. Instantaneous actuation. High pressure, hydraulic solenoids swap the clutches in less than 50 milliseconds. Because the next gear is always pre-selected, there is absolutely zero drop in the engine's relentless forward torque pulse. Rev matching. During downshift, the engine's computer blips the rotary valves instantly to match the exact RPM required for the lower gear, producing a crisp, mechanical shift without disrupting the chassis balance. 2. Custom 7-speed dual-clutch transmission DEC. If the goal is to emphasize the completely unbroken torque path during gear changes, a DCT is the premium choice. Why it works? A DCT pre-selects the next gear using two separate shafts and clutch. When you shift from one gear to the next, one clutch opens precisely as the other closes. The gearbox responds, because it takes a fraction of a second to select gears. The engine's relentless sinusoidal power pulse never suffers a loss in momentum, keeping the acceleration perfectly linear. Automatic urban mode. Intelligent torque management. With a selection, the transmission transforms into a fully automated, silky smooth commuter. Predictive gear change algorithms. Because the engine has a strict 2099 RPM ceiling, the gearbox software monitors throttle inputs and road load to execute early upshifts. It surfs the engine's flat torque curve, keeping the revs comfortably between 900 and 1500 RPM for silent, effortless driving. Adaptive compound mode control. The electro-hydraulic clutches smoothly feather engagement at low speeds, preventing the lurching common in traditional racing gearboxes during Stapango city traffic. Structural alignment with the drive shaft. To maintain the compact, straight-line architecture of the axial engine, the EDCT uses a concentric, dual-input shaft. Instead of standard gears lining up on bulky side-by-side countershafts, the gears are nested inside one another. Shafto, in-ear shafto clutch 1 controls the odd gears 1, 3, 5, 7 on a solid inner shaft. Clutch 2 controls the even gears 2, 4, 6 on a hollow outer shaft that spins right over the inner one. The result? The transmission casing retains a slim, cylindrical profile that bolts directly to the back of the engine core, preserving a perfectly straight torque path down the center of the vehicle. It refreshes 60 times per second, 60 Hz. There is a strict physical limit to how fast an object can spin in a 3D simulation before it triggers an optical illusion. When the speed of the rotation syncs up with the frame rate, the continuous movement can no longer be tracked. The central shaft rotates exactly 90 every single frame, causing the mechanical timing to look erratic or stuttering. At approximately 30-39 RPM, the shaft rotates exactly 180 per frame. Because a symmetrical object flipped 180 looks completely identical to its starting position. Each new frame captures the engine in the exact same orientation. As a result, the entire mechanism appears completely frozen in midair. This is a classic digital manifestation of the stroboscopic effect, where high-speed rotation outpaces the discrete sampling rate of your screen.